Hi guys, we're going to do Unit 3, Section 3, and this is our growth equation. This equation, let's call it growth formula. This formula is going to be used anytime we're talking about increasing, so let's write that down. We're talking about growth, increase, let's see, appreciating means it's going up. Anything that means it's going up in value or number, okay? If we're going to do that, we're going to use this formula. Y equals A parenthesis 1 plus R closed parenthesis raised to the T. Now let me tell you what each thing in here stands for. The Y is going to be our final number, whatever we're talking about. If we're talking about population, that'll be the population, the final answer at the given time. All right, so we have to give you a time and then you can get a final answer. Population, money, all kinds of things if we're talking about bacteria growth, stuff like that. All right, so the A in this problem stands for our initial or starting value or amount. Okay, so you kind of have to know where you start it to know where you're going to end up. Okay, now the 1 is often sometimes confuses people. The 1 stands for we're going to add in 100% of what we started with. So the 1 is actually a 100% in decimal form. So we really need to add in the original amount, and in order to do that, we're adding in 100% of the original. Okay, so that's always a 1 there because we always want to add it back into what we originally had. So that's 100% of the original. Now to see the growth, that's where the R comes in. And that's the rate of growth. Now you have to be really careful. It cannot be in percent form. It has to be in decimal form. So you have to change your percent to a decimal. And that's also going to be added to what we originally had. So we're going to figure out how much we're going to add the original 100% of what we had and then a percentage back in. And that's why we have a 1 plus the rate, okay? And then the T stands for time. And that could be days, that could be seconds. If we're talking about bacteria, we're talking about maybe even milliseconds. We're talking about a small amount of time. We could be talking about years. We could be talking about decades. You have to read the problem to know, okay? So this is what everything stands for. We're going to do 2 example problems and then you'll have 3 for homework. So and the first one we're just going to do straight out and solve it. So if you need to pause right here, I'm going to scroll in a minute. If you need to pause to make sure you get this all written down, go ahead and pause. But here's my first example. Let's change colors. I'm tired of blue. Okay. It's a word problem, so I'll give you a minute to write this down. Or again, you can pause it. That's the kind of the nice thing if I'm going too fast. It is estimated that the population of the world increases an average annual. In case you don't know what annual means, that means yearly. And you'll see that word a lot when we're talking about growth. Rate of 1.2%. If the 2016 population was about 7,350,000,000. That's 6 zeros. Predict the 2025 population. Now, of course, it looks like this book was written a couple of years ago, so some of these numbers probably have changed, and in our current climate, we're probably seeing some change also. But we're just going to use these numbers for now as an example. If you need to pause, go ahead and pause. I'm going to continue. So let's get our numbers here. Y is going to be, I'm just using the letters from the equation above. Y is going to be our predicted, so this is what we're looking for, population in 2025. Now, we all know it's predicted. No one predicted what's going on right now, so we don't know how that's going to change these numbers. We can use math all the time to make good predictions, but that's all they are, is they're predictions. We can't always take into account everything else that's going on. Okay? Our original starting population when this problem began was 7,350,000,000. So that's going to be our A value. And make sure you get all your zeros in there. You'll be off by a couple billion or million. Okay? 1 is always going to stay 1 because remember, that's our 100%. So that just stays as 1. So we want to add back in is our original 7 billion, and now we want to add some numbers to it. So we have to talk about the R. The R is 1.2%. Now don't be deceived to think, oh, well, there's already a decimal in it, so it's in decimal form. It is not in decimal form as long as there's a percent sitting next to it. In this case, there's a percent sitting right here. So that means per 100. Per 100 means in order to get this into decimal form, we need to divide by 100. That's what percent means, per 100. And so really, our decimal is 0.012. That's our rate of growth in decimal form, okay? Now to figure out our time, we have to figure out how many years between 2016 and 2025. So we take 2025 and we subtract 2016. And that tells us there's 9 years. Now we have everything we need to plug into our original equation. So I'm going to write out the original equation in letters so you can see that we're just substituting. So y equals a parenthesis 1 plus r raised, or closed parenthesis, raised to the t value. We don't know our y, that's what we're looking for. We do know our a, it's 7,350,000,000. Make sure you get all those zeros in there. Parenthesis 1, we already figured out our rate, is 0.012, and we're raising it, close parenthesis, and then we're raising it to the 9th power. At this point, now this is where people get confused. I'm not trying to graph this. So I'm not going to my y equals. I'm just going to my home screen, and I'm putting in 7,350,000,000, parenthesis 1 plus 0.012, close parenthesis, raised to the 9th power, and then I hit my enter. So this is not a graph. We're not trying to graph it. We're just trying to get an answer. So just because there's a y equals doesn't mean we always jump to y equals. You have to stop and use your brain and think, am I trying to get an answer? Am I trying to get a graph here? And in this case, we just need a number answer. So that's in our home screen. So once you put that in, you will get 8,182,988,703. That's going to be the estimated population if the growth rate continues, if nothing interrupts it and it continues, it'll in 2025, according to this information, that's what our population would be in the world. Okay, again, if you have, this is where I would normally stop and say, what questions do you have? Ask me where this number came. You might have to leave yourself some notes, like where did this number come? Highlight it, ask yourself, and then when I see you in my video conferencing time online, then you can say, I didn't understand where you got this number, and I can answer that question pretty quickly. Okay? Please don't bring nothing to the meetings that we have. Don't come and say, I didn't understand anything, because I can't really help you with that. I'm going to say, did you watch the video? Did you write some things down? Now, what specific questions do you have? Okay? Because you need to engage your own brain first so I know where to help you and where you're having difficulty. All right, let's try one more example. Again, up to you if you need 2 examples or not. You might want to try the homework, and then if you're not getting it, maybe come back and listen to the second example if you want. But it's up to you. But here's example 2. The equation represents the population growth in the United States beginning in 2016. So in this case, I'm going to give you the equation, and you're going to have to answer some questions about it. Okay? So here's the equation. I'm going to give it to you. Y equals 321,400,000 parenthesis 1.008 raised to the t power. So that's the equation. I gave it to you in a little different form. What you probably notice is there's not a 1 plus a rate. If you need to, you could rewrite this and split the 1 from the rate if that would help you. And so this is what it would look like. 321,400,000 parenthesis 1 plus 0.008 raised to the t power. Now, if you see this in other places, you won't often see the 1 plus, but you have to understand that 1 is added because we have to add in the original population to the new population. Okay? So let's ask some questions here. A, what was the population in 2016? Now, instead of just sitting here and waiting for the answer, pause it. Look back, think about which number up there represents the initial amount. Look back in your notes. Use your brain and think. What was, if we were starting in 2016, what was the original population? What you should have come up with was 321,400,000. That was the population in 2016 because that's when this problem began. And the number in front of the parentheses, the A, is our initial amount. Okay, now let's look question B. What was the percent of growth? Now you have to read this carefully. I asked for a percentage. I did not ask for a decimal. In the original problem up there, it's in decimal form because that's how it has to be in an equation. Well, if we divide a percent to get to a decimal, what do we need to do to a decimal to get to a percent? We have to do the opposite. So we're going to take 0.008 and we're going to times that by 100. And that will give my percent of growth, which is 0.8%. That's my growth percentage per year. Okay? And then C, I kind of answered for you already, so I'm going to just leave that there and see if you can answer it. And if not, you can ask me later. What does 1.008 stand for? And I'm going to leave that. And if you can't figure it out, you can come to my office hours and ask me. Okay? And then the final question is going to be this, D. If, let's make that capital, if the growth rate stays the same, what would the predicted population be in 2030? Again, this is a prediction. This doesn't take into account everything that's going on right now. So we just have to go with that, okay? So let's fill in what we know. We already have our equation. It's y equals 321,400,000 times, parenthesis, 1.008, and now we just need to figure out the years. So we went from, so we have to figure out the time. So I want to know the prediction in 2030. This problem started in 2016. So I'm going to say t equals 2030 minus 2016, and that gives me 14 years. So I want to know if the time is 14 years, what's going to be the population. Again, this is where you get your home screen of your calculator. You plug it in, and what you get is something a little strange here. You get 359 million, which is higher than what we have, which is good. 329,871.4. Well, mathematically speaking, that's wonderful. But if we're talking about people, we really don't want to talk about 4/10 of a person. And we want to be careful making jokes about what 4/10 of a person means, because that could be insulting. So we need to put that in math terms. And really, we would probably round up in the real world, if we were just talking real world, to 360 million. We'd probably round that clearly, because that's what we would see as the important values, okay? So we would round to there. So we wouldn't, if I asked for a word problem answer, make sure you're talking about what makes sense. 4/10 of a person doesn't make sense. Mathematically, algebraically, that's completely correct. But we want to go with the word problem. Now, if I don't tell you what to round to, you could still give me 359,329,871, because you should know that 4/10 of a person is a mathematical answer, and you need to fix it and make it so that it makes sense with this word problem. Okay, so you're going to have 3 problems for homework. I want you to try all 3 of them. They're not going to take you that long. Again, I'm going to have office hours, so if you need help, please make sure you highlight what you want to ask me, because we have to make sure we use our time wisely. And if you're having trouble with this, maybe watch the video again, or I also included a Khan Academy video. Thanks for watching.